Hi, welcome to our pre-calculus. The topic today is solving a word problem using the law of cosines. So here's a reminder of the laws we have learned so far. The law of cosines, for example, a squared is equal to b squared plus c squared minus 2bc cosine of a. We said that's the generalization of the Pythagorean theorem. We have something called simplified law of cosines. Sometimes comes in handy for calculating uh, one of the sides of the angles. And then we had the law of sines, which was telling us the ratio of sine of an angle to the opposite side is the same for all three corners. So let's go ahead and take a look at these problems. This one says Yoko is flying two kites. She has 99 feet of string out to one kite and 115 feet to the other kite. She observes that the angle between the two strings is 28. So this angle is 28, and sorry, the angle is 28. What we want to do is to find the distance between the two kites. Well, this is a simple example of side, angle, side, and a simple application of any of these laws of cosines that we have here. So the only thing is that the letters are not attached to these quantities. You can label them however you want to label them. So for example, this can be the vertex C, vertex A, vertex B, for example. In that case, this is side opposite of C, so that's, we're going to call it little c. This one would be little b, little a, and so on. And therefore, we'll have c squared is equal to a squared plus b squared minus 2ab cosine of c. So that tells us c squared is equal to a is 99, b is of 115, minus twice 99 times b, which is 115, times cosine of c, and c is given to be 28. So this is a straightforward application. There is nothing special to do, and we just need to calculate this thing, and then we are all going to be done. So we go ahead and calculate c squared first. So I get 29, 12, no, 29, 21, sorry, over 2833. And we calculate c now. C is going to be square root of this number, is going to be 54.048, and it says carry out intermediate calculations. If you want to do it piece by piece, do it to 4 decimal places, and at the end write it to 1/10 of a foot. So this one is going to be 54.0 when you round it. You might as well put everything under one string of operations, so that your calculator calculates everything to the maximum level of accuracy it can do, as opposed to writing step by step. So the best way to do this thing is to write from the beginning as square root of 99 squared plus 115 squared minus 2 times 99 times 115 times cosine of 28 That might not easily fit on the screen of the calculator, but that's the best approach for doing this kind of calculations. You get the best accuracy if everything is done from beginning to end inside one line of computation. Second problem we have here is we have 3 islands. Hans is on a vacation at a tropical bay that has 3 islands. He rents a boat on island A and plans to go to island C, which is 14 miles away. Based on the figure below, find the angle theta. So he wants to go in this direction. He wants to know the angle that his path is going to make with the one that would have gone from A to B. So again, labeling sides with the letters opposite them. This is going to be C and this is going to be B. When you want to find this angle, we have cosine of A is equal to B squared plus C squared minus A squared over 2BC. How do we remember that? These are the two adjacents squared minus opposite squared divided by twice the product of the adjacents. So this, the way to remember is that these are adjacents of the angle. This is going to count as the opposite of the angle, and again these are the adjacents of the angle itself. So again, we're just going to go ahead and type the numbers in, and let me ask you, what would be the way to go ahead about the computation so that you get the maximum accuracy? So we have to write it as A. Here is cosine. That means I need to have cosine inverse of whatever is on the right hand side. And we said the advantage of law of cosines is that you don't need to worry about an alternate solution and going and checking the two possibilities. Whatever cosine inverse gives, that is all we need. So in this case, let's go ahead and enter this thing on the calculator. So putting the numbers here, and so here you have 14 squared and 8 squared minus 15 squared divided by twice B and C. That's 14, and C is 8. Another possible cause of error in these problems is on your calculator. Either you have to visibly see that this is in the denominator, or put the whole thing in the parentheses to be absolutely sure you are not confusing multiplication and division. At any rate, with this computation I get 1.5625, and inverse cosine of that I get 81 degrees 0.01 and 0.07, and then we you round it to as many decimal places as it might be required. Okay, so these two problems were straightforward. Not much was requested in either of these problems. So just remember, if you have side, 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 law of cosine is applicable. Side, angle, side, also law of cosine. After the very first step, you can apply the law of sines or simplified law of cosine to find the remaining quantities, either way. And we had previously looked at the law of sines in similar context. Until next lecture, good luck and God bless.